All right, earlier I mentioned that you could compare ints and doubles using equals equals or less than or equal to, greater than, all that kind of stuff, and that makes sense. Okay, we're pretty familiar with doing that. What you may not be familiar with is comparing characters, like letters. Um, Now, you can kind of think about that a little bit as far as like alphabetical order. You can think, oh, well, Z is greater than A because Z comes after A. That kind of makes some intuitive sense, and that will help you here. But we're going to take it even a step further. So every single character that we use actually has a number associated with it, because everything in a computer has to be stored as a number anyway. So basically, whenever you type something in the keyboard, it goes, okay, this is the number that they chose, and this is the character associated with that number. So we have to, every single character has to have a number associated with it. Lowercase a through Z, uppercase a through Z, but also stuff like exclamation point and brackets and even Arabic and Mandarin and, Slavic characters. All of those need like a number attached. And so what they did is they developed a system for this. Now, at first, we used a system called ASCII, American System for Communication and Information Interchange, I think. Okay, you can look that up later and double check me there. But basically, it was this American system for taking characters and having a number associated with that. Problem is, everyone kind of developed their own system, and ASCII wasn't very standardized for some of the later ones. So what they did is everybody came together. They came up with something called Unicode. Now, the good news is Unicode uses the same values at the beginning. So like the early numbers are all kind of the same, and then everybody got on the same page on the later numbers. But here's some examples here. So like 33 is exclamation point, 43 is the plus sign, 65 to 90 are your uppercase, and then you got some symbols in between, and then 97 to 122 are your lowercase values. So you'll notice a few things here. So like we said before, Z comes after A. So Z would be considered bigger than A, but A would be considered bigger than uppercase Z. So case would matter here when you're comparing these characters. So that's what we use here when we're comparing these characters. Is it's going to use their ASCII value or their Unicode value. Something else to take note of here is in Java, you can do mathematical operations on characters. Now, when you do that, whenever you take letter plus 1, what that does is it says, okay, I'm going to take that letter, and since you're wanting to do math with it, I'm going to change it to an integer. So it immediately converts it to an int. So when I do my letter plus 1, it's going to do A and convert it to an int. So it's going to convert it to 97. And then it's going to add 1 to it, and it'll be 98. So it'll say, okay, I took my character, I added 1, so I converted it to a number, and now I'm going to print out 98. Now here, it's going to do the same thing. It's going to convert it to an int. It's going to add 1, make it 98. But when I convert it to a character, okay, when I cast it as a character, it's going to say, oh, okay, 98, that's B. So it converts it back to a character. So if you do choose to do math on it, just know that it converts it to an int, and if you want to convert it back, you're going to have to do that casting. You're going to have to do parentheses, char, and close those parentheses there to cast it. So you can treat characters as number for comparison, and even for doing calculations. Kind of cool.